Given, n numbers in a fixed left-to-right order. Patience solitaire is the mental model, piles in a row, and we only show each pile's top. The fast view keeps sorted pile tops as an increasing tails row and uses binary search for each new value, logarithmic time per step. When the scan finishes, the length of tails is the longest strictly increasing subsequence length. Overall, that is order n log n time and order n extra space for the tails row. Sample nums 3, 1, 8, 2, 5 yield tails 1, 2, 5, so the LS length is 3. First, the patient solitaire picture. Each number goes on the leftmost pile whose top is still bigger, otherwise start a new pile to the right. When the deal is done, the tops in order are the tails row we use next. Because tails stays sorted, each insert uses binary search to find the first tail at least the new value. Index 0, value 3, tails is empty, so we append. Length is now 1. Index 1, value 1, it replaces the first tail. Tails is now just 1. Index 2, value 8, bigger than every tail, so we append. Length is now 2. Index 3, value 2, first tail at least 2 is 8 at index 1. Replace it, tails becomes 1, 2. Index 4, value 5, bigger than every tail, so we append. Length is now 3. Index 5, value 4, first tail at least 4 is 5 at index 2. Replace it, tails becomes 1, 2, 4. Index 6, value 9, bigger than every tail, so we append. Length is now 4, the LS length. The tails row ends as 1, 2, 4, 9, length 4. The chain 1 to 2 to 4 to 9 in nums is one matching strictly increasing subsequence. Time is O of n log n, one linear scan, and each step does binary search on the sorted tails row. Space is O of n for that tails array. Main routine, longest increasing subsequence length using a greedy tails row. Tails starts empty, it will stay strictly increasing. Walk the input once, left to right. Call lower bound to find where x belongs in tails. If that index equals the current length, every tail is smaller than x. Append x on the right as a new pile top. Otherwise we overwrite an existing tail instead of growing. Replace tails at that index with x, tightening the row for future values. When nums is done, return how many tails we built. Lower bound helper on the sorted tails list and value x. Search window is low through high, initially covering all tails entries. Repeatedly have the window until low meets high. Mid is the integer halfway point between low and high. If the value at mid is still below x, the first valid slot is strictly to the right. Move low up to mid plus 1. Otherwise the answer is at mid or to its left. Shrink high down to mid to search that left side. When low equals high, return low as the insert or replace index.